Okay, so to finish off section 8.2, we're now going to talk about the four-step process, and I've tried to allude to that previously in other chapters. But this is the process that we're going to basically use for the rest of the course. So when a problem asks us to construct and interpret a confidence interval, we're going to do four things: state, plan, do, then conclude. And you can think of it as statistics, problems, demand, consistency. And that's really going to help us get good grades on the AP test. We're going to use this for the next thing that we learn as well. So statistics, problems, demand, consistency. So we state what parameter we want to estimate and at what confidence level. For the plan, we identify the appropriate inference method and check conditions. So right now we only have one type of method. It's the one sample Z interval for a population proportion. So unfortunately, you're going to have to start memorizing or understanding what some of these methods are called. The do part is, if the conditions are met, do all of your calculations. You either show the calculations or you show what you used in the calculator. And then the conclude part is we interpret our interval in the context of the problem. If you go to your textbook to the back cover is an inference summary. And we really only have one thing so far. We have the interval test, the intervals for proportions. It's called a one sample Z interval for P. And that is the first box that comes up in that inference summary. But you can see all the things that we're going to be talking about. So we have to remember all of these. This back cover will be your friend for quite a while now. So here we go. Let's do a problem where we're completing all four steps. In her first grade social studies class, Jordan learned that 70% of the Earth's surface was covered in water. She wondered if this was really true and asked her dad for help. To investigate, he tossed an inflatable globe to her 50 times, being careful to spin the globe each time. When she caught it, he recorded where her right index finger was pointing. In 50 tosses, her finger was pointing to water 33 times. Construct and interpret a 95% confidence interval for the proportion of the Earth's surface that is covered in water. Okay, so our first step is that we want to state what we're trying to find. So to state what we're trying to find, they're asking us to estimate the true proportion oh my goodness. P of the Earth's surface covered in water. So we stated what we wanted to do. Next, we're going to plan our course of action. What are we going to do to try to figure this out? So when we plan, remember, we want to say what type of method we're using, and then we have to check the conditions of that method. So we're going to use a one sample, because we only did this once, Z interval for P. So we're going to check the conditions. And the first condition that we have to check is this random? So we toss the globe 50 times to her, and the 50 locations are a random sample. Because it could land anywhere at any time. So random is checked. Then we also have to check the 10% rule. So we don't really need to check this because the locations were not selected without replacement. Okay, so we have our random, we have the 10%, and then we have to do large counts. So for large counts, remember, we need p hat. So in her sample, she touched water 33 out of 50 times. So we check our sample for large counts, and n times p hat is going to be 50 times 33 over 50, which is 33, which is greater than or equal to 10, so that's good. And n times q hat is going to be 50 times 17 over 50, which is 17, which is greater than or equal to 10. So the conditions are met. Okay, so we have that part all done. We stated what we're going to do. We planned how we're going to implement all of that. So now we're going to do the work. So now we'll do. So remember, what we want to do is we want to construct the interval. So to do that, we need to find, it's a 95% confidence interval. So we need to find our critical value, which is z star. You can use table A in the book, or you could use the inverse normal. But when we put that in there, for 95%, our critical value is 1.96. So we take our p hat, which is 33 out of 50, plus or minus 1.96 times the standard deviation, which is p hat, times q hat, divided by n. And this is all under the square root, the whole thing. And so when I do that, we get 0.66 plus or minus 0.131. So my interval is 0.529 to 0.791. So we did all of our work, we found our interval. Now we take this information and we make our conclusion. So we state, we plan, we do, now we conclude. We are 95% confident that the interval from 0.529 to 0.791 captures the true proportion of the Earth's surface that is covered in water. So we're always going to make that statement in context. So because the claim was 70% of the Earth's surface is covered in water, we can say yes, 70% is a plausible value for the true proportion of water on the Earth's surface. We'll get more into how to do that conclude later on. Okay, so hopefully that makes sense. Those 4 steps are critical. The back cover of your book is critical. That is something you need to be able to go back and find and look at and understand what we're doing. Okay, one more thing that we have to do is sometimes it's going to ask you to choose the sample size. So when planning a study, we may want to choose a sample size that allows us to estimate a population proportion within a given margin of error. The margin of error in the confidence interval for P is the critical value times the standard deviation. Because the margin of error involves the sample proportion P hat, we have to guess the latter value when choosing N. There are 2 ways to do this. Use a guess for P hat based on past experience or a pilot study. Use P hat as 0.5 as the guess. The margin of error is largest when P hat is equal to 0.5. So when we want to determine the sample size that will yield a level C confidence interval for a population proportion P with a maximum margin of error, solve the following inequality for N. P hat is a guessed value for the sample proportion. If you don't have a guess, then you use 0.5 because that'll give you the largest margin of error. Okay, so here's an example. A company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. One critical question is the degree of satisfaction with the company's customer service, measured on a 5-point scale. The president wants to estimate the proportion P of customers who are satisfied. Those are chose either satisfied or very satisfied, the 2 highest levels on the 5-point scale. She decides that she wants to estimate to be within 3% at a 95% confidence level. How large a sample is needed? Okay, so we're supposed to determine the sample size needed to estimate P within 0.03 with a 95% confidence. So since we have a 95% confidence interval, the critical value is going to be 1.96. We have no idea about the true proportion of satisfied customers, so we'll use P hat as 0.5 for our guess. Because the company president wants the margin of error no more than 0.03, we need to solve this equation. The margin of error needs to be less than 0.03. So we have our critical value times the standard deviation. We want to be less than or equal to 0.03. Since we're using P hat of 0.5 as a guess, we are actually solving this. I multiplied by the square root of N on both sides and divide by 0.03 on both sides. So we get N is greater than or equal to all of this because we square both sides. So we got N is greater than or equal to 1067.111. So that means we should probably round up to 1,068 respondents to ensure that the margin of error is no more than 3%. If this math isn't making sense right here, I think we'll talk about that more later. So here we go. Suppose we want to estimate P, the true proportion of students in your school who have a tattoo with 95% confidence and a margin of error of no more than 0.1. Determine how many students should be surveyed to estimate P within 0.1 with a 95% confidence interval. Okay, so we're going to for a 95% confidence interval, our z star is going to be 1.96 again. Our margin of error we want to be less than or equal to 0.1. So we take our critical value. We don't know p hat, so our p hat we're going to guess is 0.5. So 0.5 times 0.5 divided by n has to be less than or equal to 0.1. So the math behind this is you're thinking of this as the square root of 0.5 times 0.5, square root of 0.5, over the square root of n. So picture that. So what I'm doing is I'm multiplying this side by the square root of n and this side by the square root of n, and that cancels these. So I now have, let me get my calculator out. Okay, so I got on this side 0.98 is less than or equal to 0.1 times the square root of n. So now I'm going to divide by 0.1, and I get 9.8 is less than or equal to the square root of n. So now I got to square both sides. So I get 96.04 is greater than or less than or equal to n. So n has to be greater than or equal to 96. So we should survey 97 students, blah, 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 to ensure that the margin of error is no more than 10.1 with a 95% confidence. Okay, I hope that makes sense. That is the end of that section. We're going to put it all together now. We go into a whole different parts with means next, but we have a quiz first.